All right, when you're looking at this problem, here's the information they provide. Okay, this Tropic of Cancer line is designated up here, okay, as being 23.5 degrees north of the equator. Okay, so it means that's its latitude. So it has a latitude of 23.5 degrees. That means that the central angle formed for this arc is that angle measure, 23.5. Okay, so it's asking you here to solve for the radius of this new circle. Or, I'm sorry, solve for the circumference of this Tropic of Cancer. In order to find the circumference formula is 2 pi r. That should be something that's familiar. Okay, so you need to know the radius. Okay, so we need to know the radius of this circle formed here. So in order to find that radius, what you can see is we have a right triangle formed that involves that radius. Okay. Okay, in this right triangle, okay, there's two options to approach this. Okay, take just a second and see if you can work from this step. Okay, again, I'll just give you a minute or so, see if you can at least interpret that information and move on, and then I'll talk about some other ways to approach it. What if we use this as our angle, right? Okay, so one way to solve this is to find this angle measure. And how could you find that angle? Good. Okay, so if you take this relationship here, what is this angle going to equal? Okay, so we have that angle of 66.5. So if that's how you're solving this problem, then this reference triangle where our radius is located here has a known angle of 66.5 degrees. And then do we know this length here? Well, it is the radius of that big circle, right, the Earth. And we were told that that radius was 3960. So once we have this much information, can we find r? We have an angle, an opposite side, and a hypotenuse. So opposite and hypotenuse is sine ratio. So if you take sine of 66.5 degrees, that's going to equal opposite r over hypotenuse 3960. Okay, so I'm not going to, or we'll talk through this here in just a second. I want to show you another way that you can solve this with one less calculation. Okay? And it's just it's a matter of understanding the concepts. The concept that's covered here is very likely going to be on the SAT. It's a geometry concept. I'm sure Mr. Dobler explained it very thoroughly to you guys. Okay, and that is this line right here and this line right here are parallel to each other, correct? So what do you know about this angle and this angle? Yeah, what kind of angles? Do you remember the name for it? Alternate interior angles. Good. Okay, again, SAT is probably going to have something like that. If you use that instead, all it saves you, I mean, you're still doing the same thing. If you use the fact that this angle is 23.5, it saves you this calculation. So it saves you that time. Again, it's not necessary. We still have our radius r. We still have the known value 3960. But if you solved it this way, okay, then the calculation that you would use is you have an angle, you have the adjacent leg and the hypotenuse. Which trig ratio is that? Cosine. And so you would use cosine of 23.5 is equal to adjacent over hypotenuse. Guys, shh. And so either way, you're going to solve one of these two equations. Okay, one relationship that isn't necessarily important, but we can see it here, and we've seen it in a couple other things, is when you look at, I had brought up the term cofunctions. Okay? When you look at sine and cosine, they have similar names, right? Sine, cosine. You have tangent and cotangent. You have secant and cosecant. These cofunctions that have the names that are same except for co will always have, when you're looking at these values here, the sine and the cosines are going to have cofunctions of complementary angles that are equal. So what's the complement of 66.5? Well, so these are complements, meaning they add up to 90 degrees. And so it should make sense that you see it right here. This is kind of a demonstration of the fact that these cofunctions of complementary angles are equal. They're both r over 3960 in this case. Okay, so let's say we work to solve this. Okay, again, you guys seem to like seem to be more at ease using the solve feature for this. Okay, so if you type in the cosine of 23.5 is equal to, I'll call it x divided by 3960. Solve for x. Okay, I already have my answer in decimal, or I have a decimal in here, so it's going to give me a decimal answer. Okay, so I get this radius to be 36, 31, and then it asks you, did I tell you to? To 6. Okay. Now, what units is this in? It's in miles, right? Okay, and when you type this in, it's not getting the right answer? Right, so it's not the right answer because the question is asking you for the circumference. So let's take that value that we have and plug it in. Again, don't abbreviate it. Use the exact answer that you have right here. So if I take 2 times pi times, and we want this quantity right here, you can do two things here. One, you could just go up and highlight this number and then scroll back and delete the x equals. So I could have just done this and hit delete. Okay, and so I get my answer, which should be about 22817.8 if it was to one decimal. Okay, now, the other way I could have done this is I could have, because of the way that this was entered, so here is what I had. An easier way, or probably what I might have done just to save from having to retype all of that or go back and delete it, is I would just type the equation, 2 pi x, use the with key, and then if I highlight that, x equals, it's in the form that would evaluate it anyway. So now I can get my answer in that form. And it just saves a little bit of time.